Hey, good morning, everybody. Since I did your class yesterday, I will try and get yours done first today. I hope you guys are all up. It's 5:30 in the morning. This is when I do a lot of my best math work. I'm sorry about the video again yesterday for the audio and things like that. This should be a little bit better. I was working on it for quite a while last night. So I'm going to go over some of the things that I went over yesterday that you guys might not have been able to make out, and I'm going to go over a few other questions as well if we have some time. So first of all, there was a little confusion about where this work is located. There's a packet on the class website. You can go to the school website, I'll link to it, but you guys should know it's downstairs math. Go to the distance learning section and geometry. The same packet we've been working on in class. It is 70 pages long, and that's because we cover almost nothing but circles for the entire third quarter. So there's a reason it's such a long package. This one in particular, this information we're talking about is on, page 44. These notes right here, these notes are on page 44. Your work is on pages 46 and 47. I believe it's labeled day 5 homework, and the answers to those questions are on page 48. So you should be able by the end of today to complete any of the questions on pages 46 and 47. We're going to go through a bunch of them, and then we'll kind of take from there, kind of fill in the blanks. Whatever we don't get done or whatever isn't going over, you guys go ahead and do it yourself. Don't try and fit all your work in the package. Do it on a separate sheet of paper if you can. It'll just be a little bit easier. So anyway, without further ado, here are your 3 rules. If your angle is on the circle, and we talked about inscribed angles quite a bit, but this also works for angles that meet up with tangent lines, right? Tangent lines are the ones that kind of just skim off the edge of a circle. You're going to take the measure of the angle is going to be 1/2 of the intercepted arc. So again, so x is your intercepted arc out here. This angle will be 1/2 of that. All right, so that should be new. And in fact, none of these rules should be new. We went over these the other day in class for 2 or 3 days before all the madness happened. Okay, if you have an angle in the middle of the circle, I almost said center, but remember this is not necessarily for the center. We know that center angles are central angles, right? And that is just equal to 1, is a 1-to-1 ratio. So if it's a central angle, it is the same as its intercepted arc. This rule is actually not much different than that. It's just we have to think about it in a different way. Essentially, if we have the 2 intercepted arcs, this angle in the middle is 1/2 these 2 things added together. So if you add together the 2 intercepted arcs and multiply by 1/2 or divide by 2, remember multiplying by 1/2 or dividing by 2. So we could also say for all of these, we could also say this. Okay, you could say that for all these. So if you guys are more comfortable doing that, that's fine. This could be x over 2, and this one could be x minus y over 2. And I know a lot of people don't like fractions. That's totally fine. Just make sure you add or subtract to your top and your bottoms first. Okay. But anyway, if it's inside the circle, remember this is an average. We're taking the 2 of these together by addition and then divided by 2. Well, there was 2 things we put in. So we're really, as we kind of move this intersection around the circle, if we've kind of moved it up or down, we would be taking the average of it. Which is, by the way, is the same if we put it in the center, because if we put it in the center, we said it's a 1-to-1 ratio. Well, that means that x and y, because these are vertical angles, would both be the same. So if we add together 2 numbers and divide them by 2, we just kind of get back to where we started from. So again, there's nothing that's not true for the center about it. But again, you have intersection anywhere inside the circle, add together the 2 intercepted arcs, divide by 2. Remember that these 2 are also vertical angles. So if you know one, then you know the other. Okay? All right. Okay, and your last one, which is anytime there's an intersection outside the circle. Again, what are you going to do? You're going to take the larger arc subtract from it the smaller arc, so x minus y, and then we're going to divide that by 2, or multiply by 1/2, whatever you feel more comfortable doing. Just be careful when you get a situation like this, because if this is y and this is x, this is the rest of the circle. We know an extra piece of information. If you think about what we talked about with systems of equations last year, we don't necessarily have to call this x. We can call this 360 minus y, because we only have 2 arcs in this circle. We have this major arc and we have this minor arc. That's the whole circle. So we know an extra little nugget of information there, if you will. But if they give you both of those angles, or you can find both of those, those arcs, if you know both of those arcs, you can find those arcs, it'll make things a little bit different, a little bit easier. Watch for things like diameters here, or diameters here is a secant. Watch, because that will split things into semicircles, and you'll know things will be 180 degrees. And yeah, you should be fine. It's just pretty much taking the big arc, the small arc, and dividing by 2, and you'll get your angle outside the circle. Okay. Like we said for most of the rules with circles, none of these rules are particularly difficult. Like, it's adding, subtracting, and dividing. That's what most of us do. The problem is that there are a lot of them. There's a lot of these rules, and you have to remember them all. So, excuse me, the more you practice, the better. So, all right, without further ado, let's get to a couple of questions. Again, we're working on pages 46 and 47. I do have a bunch of these other videos I have to make for other classes and things like that, so we'll go over kind of as many as we can. I'm going to go over probably the first 3, and then a few that are further down the line. They're a little more involved. You should be able to take it from there. Okay, so it's going to look like nothing's happening, but I'll be back in a second with a new picture here. Okay, so these are questions 1, 2, and 3. Pretty straightforward. They want you to find the angles in there. Okay, so again, we are inside the circle. We're in the middle of the circle. Again, also notice not at the center. So again, what do we have to do? To find this angle, we need to find pretty much the average of these two numbers. So again, if it helps you just to find average, that's fine. But we'll say angle 1 is equal, let's be real fancy, say the measure of angle 1 is equal to 52 plus 40. Okay, and again, if you want to divide by 2, or I'll do a couple each way, 1/2 of that. Now you could distribute here, or you could just say 52 and 40 is going to be 92, and 1/2 of 92 is going to be 46 degrees. Okay, so again, you know a bunch of things now. This is 46. Right, and well, vertical angle, say this is 46, right? And then we'll also tell you this over here, that this is 134, and this is 134, because again, what kind of, these are supplementary angles going across. Now again, you don't know what these two angles are out here. You know that their average is 134, but you don't have enough information to tell these two arcs out here. So again, add the two of them together, divide. All right, the second one, this is on the circle, right? So all we know is this, is that the measure of angle 2 is equal to 1/2 of its intercepted arc, which is 134. So half of 134 is, what is that, 67? I hope it's 67. Measure of angle 2 is equal to 67 degrees. Okay, so pretty straightforward. Again, you want to divide by 2, that's fine. For number 3, they want to know the measure of angle 3. Well, it appears that we don't have this piece of information, so we're going to have to do a little bit of side work. You notice, though, that we know 1, 2, 3 of these other parts over here. So for a second, let's just call this x. We do know this. We do know that 110 plus 100 plus 80 plus x equals 360. Okay, so we can figure that out. We can figure x out. We only have one variable. So that's, was it 290 I'm sorry, plus x equals 360, right? Did I get that right? 100, 200, 90x. We're going to subtract 290 from both sides. And what are we going to find out? That x is equal to 70 degrees. Okay, so probably not totally drawn to scale, but this in here will be 70 degrees. Again, how do we find angle 3? We're going to take the 1/2 of the bigger arc that it intercepts. So this is 100 out here, right? Angle 100 minus the smaller arc, which is 70. So the measure of angle 3, 100 minus 70 is 30, so 1/2 of 30, or 30 divided by 2, is going to be 15 degrees. All right, no problems. Just hear my cats scurrying around in the background. They're not used to having company at this time of day. Good, so I'm gonna scroll down the page a little more. I'm gonna pick out a few, and then we'll kind of take it from there. Alright, so 7, 8, 9, and 10, it says, assume that lines appear to be tangents are tangents, which is great for the circle because if you notice, there's no tangent lines. Alright, so in circle Q, the measure of angle CQD is 110. So I need to break out a finer tipped pencil, I think, to write in this one. So this is going to be, that doesn't work, huh? So make that 110 degrees in there, which, I'm sorry, is 120 degrees in there, which by the way also tells us something. Here's a central angle, right, that arc CD is also 120 degrees, okay? So again, central angle, 120 degrees. It says the measure of BC is 30, arc BC is 30, okay? Remember the symbol for arc up here. And the measure of angle BEC is 25 degrees. Okay, so we got 25 degrees out here, okay? So right, just from what I noticed that we have, for this big angle, AED, that we have enough information to solve for AD, which will be the second part. The first thing they want us to solve for is DC, which we already said. Arc DC is equal to 120 degrees. And again, why? Well, angle CQD is essential. Okay, and central angles the measure of a central angle is equal to the measure of its intercepted arc out here. Okay, so they want to know AD. Right, so we're gonna have to work a little bit backwards here. So we know this. We know that the measure of angle E is equal to 1/2 arc AD minus arc BC. Okay, so again, what do we know? We know angle E, right? They told us that was 25 degrees, and we know that AD is what we're trying to find out, and BC they told us is 30. Okay, now here's where it gets to be. Oops, I suppose I need the arc sign over the 30. This is where it gets to be kind of choose your own adventure algebra problem. How do you want to do this? Do you want to distribute 1/2 to both? I'm going to say your better bet is to get rid of this 1/2. Let's multiply this side by 2. I know the temptation is to distribute that 2. You don't, because these are not separated by addition. These are separated by multiplication, so you just have to multiply this by 2. So that leaves us with AD minus 30, right? This cancels out. And 25 times 2 is 50. So again, nice and neat and organized. We're going to add 30 to both sides. And we'll find out that arc AD is equal to 80. So, I mean, again, once you know the formula, guys, it just kind of turns into an algebra problem, which I know a lot of you guys have been trying to forget, but don't worry, it'll be back next year. So the next thing they want is they want the measure of arc AB. Well, let's kind of take a look at what we've got. There's got to be a faster way to erase this. This little tiny eraser. All right. So the next thing, the measure of arc AB. Well, if we kind of fill in on our picture of this, well, we've got 1, 2, 3 of the 4 sections, and we know that circles have 360 degrees. So we could just kind of take it from there. We got 80 plus 120 plus 30 plus arc AB is equal to 360, right? It's 360 degrees in the whole circle, right? 80 and 120 is going to be 200, so we got 230 plus AB is equal to 360. Sorry, the degree sense. Minus 230 on this side and minus 230 on this side. Arc AB is equal to 130 degrees. Okay, and the last thing they want to know is they want to know QCD. So QCD is this angle right here, which without any prior knowledge seems to be an impossible thing to ask. It does, it seems like it. Again, your temptation might be to continue this and try and figure that out with that 80, but remember that 80 goes all the way up to this A. We don't know that. But here's the thing. Triangle QCD, okay? Triangle QCD is, oh my god, I don't know. Let's spell isosceles, everybody. Isosceles. Maybe that's right. I have no idea. Okay, but QCD is isosceles. How do we know this? Well, QD is a radius, right? And QC is a radius, right? Well, one of the things we know about radiuses or radii is that they are always the same length. Okay, that's the defining characteristic. That's the first thing I yelled at you guys about a circle, right? Well, what does that tell you? If you remember, the two base angles are also congruent. Okay, so again, we got to dig back a few months from when we were talking about isosceles triangles. Well, if this is 120, right, and I have 180 degrees in the whole triangle, 180 degrees in the whole triangle minus the 120 is 60 degrees. So I have these two angles that add up to 60 degrees. Well, if they've got to be the same, let's just divide that by 2, and we'll find out there's 30 degrees in each one of them. So there's going to be 30 degrees in angle C and 30 degrees in angle D. Okay, so what do we got? Angle QCD in this case is going to be 30 degrees. Good? All right, we're at the 18-minute mark. Let's do one. I'll do one more little kind of bundle of questions, and then I'll set you guys free to do a few of these on your own. Okay, so let's go new, 3 seconds. Sorry about that. New, 3 seconds. Okay, this is the last little bundle of questions at the bottom of 46. So I skipped over a little chunk there. You guys should be able to do that yourself. Okay. Okay. Let's take a look at what we know. Let's fill in some of the stuff on here. Measure of arc BC is 4x minus 50. DE, where is that? Over here, is x plus 25. EF, right up here, is x minus 15. FB is 50. And CD down here is x. All right, now the first thing before I even get to any of this, what I'm noticing is that we have all the sections of the circle. 50, x minus 15, x plus 25, x, 4x minus 50. That's the entire arc of the circle, which again we know is 360 degrees. So the first thing I would do before I got to any of this nonsense over here is go ahead and solve for x. So what do we know for sure? We know that we'll start and we'll go clockwise. So 50 plus 4x minus 50 plus x plus x plus 25 plus x minus 15. So again, going all the way around the circle, all those arcs are 360 degrees. Well, let's 4x, 5x, 6x, 7x. 50 minus 50 is 0, plus 25 is 25, minus 15 is going to be 10. Put 360 way over here. We're going to subtract 10. We're going to subtract 10. We'll find out that 7x, sorry, I'm going to move it over, is equal to 350. And if you divide by 7, you'll find out that x is equal to 50. Okay, so that's good news for us. So that means that EF is 50 minus 15. Well, 50 minus 15 last I checked was 35. 50 plus 25 is going to be 75. 50, x is 50. And over here, 4 times 50 is 200, minus 50 will be 150. So just plug in x for all those, okay? Yeah, if you had a little more complicated numbers, I would say, maybe double check on a calculator. If you want to check to see if those numbers are right, add them all up, make sure they add up to 360. They look pretty good to me. Okay, all right, so let's figure it out. Measure of angle A. Well, measure of angle A is way out here, and what do we know? That's outside the circle. So where are the two intercepted arcs? There's the small one here and the big one here. So again, it's outside the circle. So we're going to say the measure of angle A is equal to 1/2 the major, well, it's not a major arc, the bigger arc minus the smaller arc. Well, again, 150 minus 50 is 100, and 1/2 of 100 is 50. So the measure of angle A is equal to 50 degrees. Okay. ABC. Oh, I'm sorry, no, we're going across. BCA. Where's BCA? BCA. Now, I know it extends outside, but the fact that this goes from F to A is of very little consequence to us. This is still an inscribed angle. Okay. And our rule for inscribed angles is that it's 1/2 its intercepted arc. So the measure of angle BCA is equal to 1/2 its intercepted arc, which is BF. So it's 1/2 of 50, and the measure of angle BCA is equal to 25 degrees. Okay, so again, here it is, BCA, its intercepted arc is 50, 1/2 of that, 25. Okay. All right, ABC, measure of angle ABC. ABC is going to be this guy right here. Okay. ABC. Okay, and again, we have to take half that intercepted arc. So what we got to do is we have to go ahead and we have to add all these things together. Possibly easier is just to subtract the 150 from 360. You should get the same number either way. So 50 and 50 is 100, 175, 210. Okay. So what do we got? The measure of angle ABC is equal to 1/2 of, again, its whole intercepted arc. So this whole thing right here, okay? Which again is 210 degrees. Okay? So the measure of angle ABC is equal to 105 degrees. So half of 110 is going to be 105. Well, GBC, you could take 1/2 of 150, which is fine, or you could notice that you just found this. We just said this was 105, and that these two angles have to be, because they're on a tangent line, they have to be supplementary, right? So 105 plus 75 makes 180. But if you want to, we could say measure of angle GBC. Hope you guys hear that. That's my cat jumping on the chair. Is equal to 1/2 of 150, and half of 150 is 75. If you don't know that, it's because people don't spend money anymore. Okay, that's half of $1.50 is 75 cents. Okay, all right, so two more, and then I'll set you guys free. Okay, FHE. Where's FHE? I have marked as FHE. FHE is this right here, right? Again, that's inside the circle, right? So we know we have to add together FE and CD, these two arcs, and divide by 2. So I'm running out of space over here. So let's go up here. So we're going to say the measure of angle FHE is equal to 1/2 50 plus 35. 50 plus 35 is going to be 85, and 1/2 of 85 is going to be 42.5. So 42.5 degrees. So the measure of FHE is going to be 42.5 degrees. Okay, and the last one, CFD. Where is CFD? CFD, again, inscribed angle, right? CFD right here is, my cats are living their life like an action movie right behind my head. CFD right here is a inscribed angle. It's 1/2 of its intercepted arc. So we'll say measure of angle CFD is equal to 1/2 of 50. I'm sorry, it's 50. Yeah, it's 50. 50 degrees, and 1/2 of this number is 50 in here. 1/2 of 50 is 25. Okay, good. So that's going to be 25 degrees. Okay. All right. Like I said, hopefully you guys got that. Hopefully this comes out a little bit better than yesterday. I'm going to try and keep using this method if it works. Let me know if you guys got questions. And I will talk to you guys on Monday. Have a great weekend. Be safe out there, guys. Thank you.